So now we're just going to cover the Rae Systems overview really quickly. So the first one I wanted to talk about is the AutoRae Pro. And again, this is one of the instruments that you guys purchased. You right now today have 3 of them, and they're set up with the hydrogen cyanide sensor like we talked about earlier. It's an advanced single gas instrument. Again, it's got the window on the front of it so that you can look through to see the name of the sensor that it's installed. We can do AutoRae Pros for LEL, for infrared sensor, for a PID, so you can actually get a PID that small if you just want a PID only, and of course toxic gas. The cool thing is it uses the same exact sensors as your MultiRAE. So you would be able to interchange those sensors in between any of the instruments, and it's going to be helpful on your parts down the line because we're using the same parts in the single gas AutoRae Pro as we're using in your MultiRAEs. You're going to get an audible, a visual, and a vibration alarm, and this instrument is wireless capable, and you guys did purchase it with the wireless capability, so we'll be talking more about that as well. Remember, the next level of instrument are your 4-gas meters, and I had passed the QRAE 3 around the room. I refer to the QRAE 3 as a super 4-gas meter because not a lot of instrument manufacturers allow their 4-gas platform to really do anything more than the simple O2, LEL, CO, and H2S. But the QRAE 3 can actually do chlorine, ammonia, NO2, SO2. So it's a really functional instrument in that you've got more sensor choices than you would normally have in a 4-gas platform. You can get QRAE 3s in a diffusion version. So what's that mean again? If a meter is just diffusion? Just test the ambient air right around you. That's exactly right. Versus a pumped instrument, which is the example I passed around the room. Anything with a pump can draw a sample to you, or to the sensors, I should say. And then this instrument also has audible alarms, visual alarms, vibration alarms, and what they call a man-down alarm. No offense, but it's just like the pass device on your SCBAs. So if you have the man-down alarm turned on either of your instruments and you sit still too long, it's going to go into a pre-alarm to say, are you okay? It really says that on screen, are you okay? And if you don't move the instrument or acknowledge by pressing a button, it goes into what we call super alarm. All the alarms will go off to alert your coworkers that someone's down, and that way we can get to them. That's very useful in an industrial setting where oftentimes a maintenance guy will go off in part of the plant by himself. I'm pretty sure you guys are always buddy system, which is the best way to do it. And this one also has wireless capability, so we could do wireless 4-gas meters. And then, of course, we have the MultiRAE family. And with the MultiRAE family, we have 5 different versions to choose from based on the features and the budget that you're trying to work within. It's got a large, easy-to-read display, so much larger display than the old MultiRAE Plus. It also has the audible, the visual, the vibration, and the man-down alarms. It also has wireless capability. And some of the higher end units can read in part per billion, like I mentioned before. Could also have a gamma sensor available, so that'd be the MultiRAE Pro. And then the one on the end, the red one with the cartridge attached, that's actually the MultiRAE benzene. And so what's cool about the MultiRAE benzene is you can attach a separation cartridge. Remember how I said when you're taking a reading that it will measure all VOCs at the same time. It won't tell you what color the piece of paper is. It'll just give you the reading of what the gases are. With that MultiRAE benzene, it scrubs out all the background VOCs and only allows the benzene to come through so that you can get a direct benzene reading. This is useful at petrochemical facilities. Okay? So just that's the whole MultiRAE family. And again, that one's wireless, and the ones that you guys are buying are wireless also. Then we have the AutoRae family. That's the unit that's up here on the table. You're welcome to come up in a break and take a look at that. Up to 7 different gas detection sensors on that unit. The Pro version can have that parts per billion resolution on the VOC sensor. It could also have a gamma sensor. It could also have, if you'll see in the picture, what's called a Rae MET sensor. That's a little weather station that's going to give us wind speed, wind direction, temperature, and relative humidity. And they're working on taking that information and plotting it into Aloha so that you can do plume modeling. So this is high end. This is if we're strictly hazmat operations. What you guys have, the MultiRAE, is going to be very sufficient for measuring VOCs. If you ever need to take it up a level, we could talk about the AutoRae Plus or the AutoRae Pro, okay? And then finally, your calibration stations. It's called the AutoRae 2, and we can run the AutoRae 2 two different ways. We could run just the cradle by itself. That's the way we have you guys set up. So your ToxRae Pro would fit in here. You would close the hood down, and then that will start the sequence. When you're finished, just hit the red button to release the instrument. You also have your MultiRAE cradle, and it operates the same way. You'll put a MultiRAE face down, you'll close the hood, it will start the sequence. When it's all finished, you'll get a green light, and then you push the red button to release it, and you pop the meter back out of it. This is what we call cradle-only mode. So you'll have cylinders connected directly to that to feed the gas to the instrument. It's all automatic. All you guys have to remember how to do is push the button, whether you want to do a bump check or a full calibration. The cool thing is if it fails a bump check, the cradle will automatically jump over and calibrate the meter for you. So it's really super easy to use. There's also what we call the AutoRae 2 system. And the system puts an extra piece on the end called a controller, and then I can bank multiple cradles together. And I can bank up to 10 cradles, and I can mix and match them. I can have ToxRae Pro cradles, I can have 4-gas cradles, I can have multi-gas cradles, and I can mix and match up to 10 altogether. The other big difference between running a cradle only compared to running a full controller system is the cradle onlys can only accept 2 cylinders of gas. But that's more than enough for what we're doing for you guys. Of course, you only have the 1 cylinder for the single gas meters. And then your MultiRAEs are a 2-cylinder calibration. So a cradle only is fine for that configuration. If you had a MultiRAE that had multiple sensors and you needed 2 or more cylinders, you would bump up to the AutoRae 2 system, and we can go up to 5 different cylinders of gas on an AutoRae 2 system. Okay? And again, the meters can charge on the cradle. So if you see fit, you could have the meter living on the cradle so it's always on charge. I've also seen some departments that just mount the cradles right to the bulkhead in your rig. That way it's always there, always ready to go. Okay? All right, that's the overview. Now let's talk about using the instrument. So the first thing I want to start off with before you turn the meters on is that if you're going to run your bump check before each day's use using the cradle, you'll keep the meter turned off and you'll put the meter in the cradle while it's off. As soon as you close that hood down, the cradle recognizes that you've engaged an instrument, and the cradle turns the meter on in calibration mode so that it's ready to go. So remember, if you're going to use the cradle to do your initial test for the day, start with it off, cradle it, close the hood, and then after the cradle warms up, you'll just pick bump or cal to calibrate the meter. Okay? If you're going to do things manually, then you'd follow the sequence that I'm about to walk you through, just in case for some reason you're not near the cradle and you need to know how to do things manually, meaning getting into the menus. So each table has a MultiRAE on it, so let's start with the MultiRAE. Go ahead and turn on your MultiRAE. And you'll notice there's 3 buttons, and it's the middle button that's your power button. And then you've got your Y plus button. So if any of the menus ask you a question and you want to answer yes, you'd hit the Y button for yes. If what you're doing needs you to increase the number, you'd hit also the yes button for the plus button, so the Y plus button. And then the other button on the right side is your no minus button. So if a menu feature wants to ask a question and the answer is no, you'll hit the no button. Or if you need to make a value go down, you'll hit the no button to use the minus button. So the Y plus, the no minus, and then the button in the middle that says your power button. So the warm-up sequence on the MultiRAE is about 90 seconds. You'll get some good information out of it. The most important piece you may want to watch for is the last data calibration, just to make sure that it's been calibrated recently. You know, months and months from now when you've forgotten who I am and you turn the meter on and you see it hasn't been calibrated in 6 months, you may want to run by the cal station first before you use the meter. So just watch for that last data calibration. Other than that, you guys are going to get comfortable enough with this meter where you'll turn it on and then you'll set it to the side while it does its warm-up, go get some other equipment ready, and then come back to the meter at the end. Because at the end of the warm-up sequence, it's going to ask if you want to do a fresh air calibration, which is going to kick you off into these 3 steps, okay? So I'm going to explain these 3 steps. They're very important. I've developed this over 22 years of doing this. The first step is always to do a fresh air calibration. You don't have to do the fresh air. You could skip it, but I like to start with a fresh air calibration because you never know if the person before you maybe shut the meter off while it still had some gas inside. Of course, the pump's running, but I just like to start with a fresh air calibration if you can. Make sure you're in fresh air if you're going to do that. The next step I'll show you how to do is a pump stall. Remember the very first slide when we talked about getting the air you're about to work in or breathe to the sensors in the meter? Well, that won't happen if the pump's not working well. So we want to make sure the pump's working well. I'm going to show you how to test that. And then the final thing is the bump check. And again, we explained that. A bump check allows you to see the sensors responding to gas, and now you know this meter is going to work correctly when you need it to. Again, if you're going to use the AutoRae 2 calibration cradle, all of these steps are done for you. If you needed to start up the instrument and run these steps manually, these 3 steps are how you want to start off. Okay? So let's talk about the first one. After you've turned the instrument on and it's run through that 90-second warm-up, the MultiRAE will ask you, do you want to do a fresh air calibration? And you have the choice with those soft keys to either say start or quit. So has everybody's meter gotten to that stage? So everybody go ahead and say, you still warming up?
Looks like it's ringing, but I never got that step.
Oh, it just went right to it. So that's your all's meter. So before I get out of the building, make sure that we reprogram that to ask for the fresh air calibration. It's easy to do, and I'll show you how to do it. So you want it to ask you for the fresh air calibration, just to remind you that that's the step you want to do. So everybody else go ahead and say start for that, and it's going to start a 60-second countdown. So make sure you're in clean ambient air. You'll press the start button, and this will zero out all the sensors. They'll all read 0 except for which one? The oxygen, and it will read 20.9. So think of a fresh air calibration like hitting a big reset button. You're just telling the meter, hey, you're in fresh air, reset all the sensors, okay? So I know you guys are counting down. I'll jump ahead while we're letting that finish, and we'll get to the next step. So step 2 is doing a pump stall. And a pump stall, again, super simple. You're just going to put your finger over the inlet of the instrument after this fresh air cal's done, and it's just going to stall out the pump. So you'll see that the little pump icon has an X on it now, and then to restart the pump, you just press the Y button, okay? Now the tricky thing is you do have to be on page 1 when you press the Y button to restart the pump. If the beeping and the flashing kind of freaked you out and you've hit another button and moved on to another page, it's going to stay in that stall mode until you're back to page 1. So on page 1 is where you'll hit the yes button to restart your pump. So when you guys get to the end of your fresh air calibration, go ahead and test that so you've gotten familiarity with it. If the pump does not stall, well, that means it's not working properly, and you'd want to put that meter down and choose another one or turn that in for service, okay? So that's your pump stall. And again, notice the little pump icon will have an X on it to let you know that the pump stalled out. Great, sounds like you guys have that. So the next step is your bump check. And this is where you'll literally take your cylinder of gas. Again, this is if we're doing this manually. You take your cylinder of gas with your regulator engaged, and you'd simply attach your meter to the gas and just watch what happens. The meter doesn't know if you're in a confined space or if you're drawing from a cylinder because you're in regular run mode. It's just going to start reacting to the gas, and that's how we confirm for ourselves that the sensors are actually working properly, okay? It's called a bump check, and all the manufacturers recommend that you do a bump check before each day's use. Now, I know you guys, first responder world, you're not necessarily going to get up every day and want to bump your meters, but you've done this long enough, you kind of know when you're on a run where gas detection is going to be involved. And so when you get there on scene, that's when you can run the bump check, whether that's because your AutoRae 2 cradles are installed in the rig or you have a cylinder of gas that's going to allow you to do that bump check. Again, it's the best way to know that the meter's working properly. So what are the 3 steps? What's the first one? Fresh air calibration. Second step? Pump stall. And then the third step is a bump check. Yep. All right. And again, if you're doing the bump check and your numbers are off by 20%, well, that just means it's not reading super accurately. You can make the decision if you're going to use it or not. I'd probably want to recalibrate it if it was off by 20%. But if I'm trying to get to 50 ppm CO and I'm at 48, that's good. You know that the meter will detect CO. The most dangerous thing you're watching for is when you put gas on a meter and the sensor just sits at 0. Okay? That's what we're trying to catch when we run a bump check. So a few things about using your gas meter, especially your MultiRAE. The golden rule is always have that filter engaged in the top of the instrument. That's going to keep out the dust and the dirt and the liquids. Remember, there's circuit boards inside there. Circuit boards don't like to be wet, so make sure there's always a filter attached. Remember, you can use sample tubing to draw gases from a distance, and the Rae Systems meters can use 100 feet of tubing. So if you needed to add 100 feet of tubing, you can do that. Just remember, just like a fire hose, it takes a little time for the water off the hydrant to come out of the other end of the fire hose. The same is true for your sample tubing. If you're drawing through 100 foot of tubing, you're going to want to delay checking the readings until after 100 seconds has expired. So it's kind of easy to remember, about a second per foot of tubing. If you're only using 30 foot of tubing, then you'll wait 30 seconds. And remember, gases might layer themselves in a confined space, so I would drop it in 5 feet, wait for the appropriate amount of time to see your reading, drop it in another 5 feet, wait 1 second per every foot of tubing, and then drop it in again. So every level of the space you want to take your measurements. And then, like I showed you earlier with the coffee-colored tubing, anytime your filters or your tubing gets dirty like this, you just want to replace it. These things are fairly inexpensive, so we don't want to jeopardize our readings by using dirty tubing or dirty filters. And then, I say this jokingly a little bit, but I'm also somewhat serious. Once you've gone through those 3 checks, forget that you have the meter. Strap it on your belt, connect it to your radio strap, and I would just forget about the instrument until it starts to beep at you. Once it starts to beep at you, now we have a reason to start looking at the instrument to figure out, well, what was it that put me in alarm? So it could be that your sensors are in high alarm, meaning they've exceeded the high alarm limit. You're going to get 3 beeps and 3 flashes per second, and it just means that you've exceeded the high limit alarm on that particular sensor. Bear in mind, your MultiRAE is a 5-sensor instrument, so you could have multiple sensors in high alarm simultaneously. It's also not too far-fetched to think that you could have a high alarm on one of the toxic sensors and a low alarm on your oxygen because the oxygen's been pushed out of the space. So you could have a low alarm and a high alarm going off at the same time. So that's the next one, is your low alarm, and it will beep and flash at you 2 times per second. Once you get comfortable with this meter, you'll just be able to hear the difference between a high alarm and a low alarm. The next alarm I'll talk about is NEG. It stands for negative sensor drifting. Rae Systems put this in a long time ago because it doesn't make sense for a sensor to go from 0 into negative numbers. There's no such thing as negative 10 part per million CO. What that means is the sensor has started to drift and we just need to get a new baseline set. So the correction for a negative sensor drift is just to do a new fresh air calibration. That big reset button just to set all the sensors back to 0. If you ever look down and you see the LEL sensor says off, that means the sensor reached 100% of the LEL, the lower explosive limit, and the sensor shut itself down. So it won't burn out and so it won't be a cause of ignition. Okay? So if you ever look down and you see that, that's a very dangerous situation. Back out of that space as quickly as you can. Battery, once the battery starts getting low, it will start flashing battery at you to let you know that the battery's getting low. Memory just means that the data logging memory is starting to get full, but what I would encourage you guys to do is set the memory just to overwrite the oldest data, and then every month when we're doing the calibrations, we can just go through and download that data, save it to your computer. You know, it's a very litigious society these days. Everybody wants to sue somebody. So when you keep good documentation that you're maintaining your gas detection, it can be helpful down the road. So I would recommend downloading your data files. And then the last icon here is a little picture of a cylinder. If you see a picture of a cylinder, next to any of the sensor names on the face of the instrument, it's trying to tell you that it's either due for a bump check or due for a calibration. So just recognize that. When everything's good to go on the meter, there'll be a big check mark at the top of the screen. Okay? So as I mentioned, there's the 3 buttons on the face of the instrument. They line up with what we call soft keys, kind of like the old cell phones did. Whatever the word is over the button, that's what that button does on that particular page. First, let me explain that main gas reading page. So it's a lot like a cell phone. Across the top of the screen, you'll see the little icons. For instance, the antenna icon tells us that we're a wireless instrument. If the antenna is flashing, it just means it has not connected to a wireless reader. If it has connected to a wireless reader, it's going to have a solid antenna and the number of bars to tell you how strong the signal is. Moving across, there's the little pump icon, which should be toggling back and forth to let you know that the pump's working. You should have a little picture of a floppy disk. For you young folks, that's how we used to store information in a computer. The floppy disk just means that it's data logging information, and then you've got a battery icon just like on your cell phone. Then in the middle of the screen are all your gas readings, and each gas reading has a label and the value that we're reading, so whether it's reading in percent or in part per million. And then at the bottom of the screen are those soft key icons. So everybody hit the no button to select that right arrow. And the next page of information on your MultiRAE, what's it say at the top? Peak. So what peak means, it's the highest reading since you've had the instrument turned on. And so whatever the highest reading for each channel will be displayed on the peak page. Go ahead and hit the arrow button again. So the next page should say min, yep. And min means the lowest reading since the meter's been turned on. And so really, since all the sensors start at 0 except for the oxygen, this is just the page that shows you what your lowest oxygen reading has been. Hit that arrow button again, and what's the next page? STEL, okay. STEL stands for short-term exposure limit. It's a 15-minute calculation, and what you guys should be seeing right now is all dashes because the instrument hasn't run for 15 minutes yet. So it hasn't had time to calculate that short-term exposure limit, but just think of this as your 15-minute alarm. If the meter calculates that you're going to be overexposed in a 15-minute period, you'll get an alarm on this screen to show you that you've reached the short-term exposure limit. Hit your arrow button again. What's the next screen say? TWA stands for time-weighted average. This is the related page to the short-term exposure limit, except time-weighted average is your 8-hour reading. So what the instrument does is it calculates based on your current exposure. If you stay at this level, your reading will eventually reach a time-weighted average. So think of that as your 8-hour reading, okay? If it exceeds what OSHA says you should be exposed to in an 8-hour period, you'll get the time-weighted average alarm. Side note that your short-term exposure limit and your time-weighted average alarms only register on the toxic sensors. No such thing as a time-weighted or a short-term exposure to oxygen or to flammable gas, because that is not a normal gas to be exposed to, okay? Go ahead and hit your arrow button again. What's the next screen say?
Date and time.
Date and time, so self-explanatory. I would recommend making sure that date and time is correct, because when you run the calibration, it's going to timestamp it based on the date and time that's programmed in the meter. So if we hit a time savings setback on the clocks and you notice the time's off by an hour, or if it's just off altogether, let someone know so we can get that date and time programmed properly. Go ahead and hit your arrow button again. What's the next screen say? Temperature and humidity. So remember when we talked about your PID sensor? What's the main component of your PID sensor? It's the glass light bulb that's in there. So if I had a big glass of ice water sitting on this table, what would happen to the outside of that glass? Start to condensate a little. And remember, moisture is one of the enemies of the PID lamp. So it's best to have the instrument to be about the temperature of the gases that you're sampling. But again, I'm talking to first responders, so if you have a cold instrument and you need to go into a building where you're taking warm air samples, yes, some condensation might occur, but again, that would just be a cost recovery if it ruins the lamp. The purpose of this is if you had the time to acclimate the meter to the atmosphere you're testing, that temperature readout will help you do that. Go ahead and hit your arrow button again. What's the next screen say?
Battery type, voltage.
Battery type, what the voltage is now, and what the voltage will be when it's ready to shut down. So usually you get down to 5% before the meter's going to try shutting down. So just remember, it is a rechargeable battery. You only have so much time. I think it's a 16-hour runtime. Go ahead and hit your arrow button again. What's the next screen say? Current runtime, and then previous runtime. So I'll be honest with you, for the longest time I wondered, why do I need to know previous runtime? And then literally 3 months ago, I thought of a way to use that. If you ever have a question about whether or not the battery is running long enough, in other words, you think maybe the battery's starting to fail, charge the meter full, turn it on, let it run until it dies, then come to this screen and see what the previous runtime is. If you get a crazy number like it only ran for 2 hours before it died, then yes, you have a battery problem. But if you get 12, 14, 16 hours of runtime, you're good. So I finally figured out previous runtime. There's a good way to use that. Go ahead and hit your arrow button again. What's the next screen say? Okay, and then at the top of the screen, does it say LEL or VOC?
VOC gas status.
Very good. So VOC gas status, and some of you, depending on my demo meters that you're using, could see LEL gas status. It's reminding you what your current settings are. So VOC gas status, it's going to remind you that you're using the 10.6 electron volt lamp. It's going to point out that your calibration gas is isobutylene. And out of the box, it should say that your measurement gas is isobutylene. If someone were to go into the menus, which I'm going to show you how to do this, if someone were to go into the menus and reset the correction factor to get a more precise reading, this is the screen you'd come to see if that correction factor has been changed. And it will tell you what that factor is. Okay? So side note, if I've talked too long, after 30 seconds, your screen will want to go back to page 1. If it does that, just hit your arrow button until you're caught up to the page that we need to talk about next. So everybody go ahead and hit your arrow button if you haven't paged back to the home screen yet. And the next one should be LEL gas status. Is that right? Very good. Same thing with the LEL sensor. It's telling you, hey, here's your LEL sensor. I'm calibrated to methane, and my measurement gas is, and it should be set to methane as long as none of these have been reprogrammed. And remember, when you're dealing with unknowns out there, you always want to be set to your cal gas, which is methane, until you've identified what you're dealing with. Then you can apply a correction factor. Okay? Go ahead and hit your arrow button again. What's the last page say? Enter communication mode. So everybody go ahead and say yes to that or select it, because I want to point something out to you. Enter communication mode has nothing to do with it being a wireless instrument. That's happening all the time. Communication mode is for maintenance. And so it's asking you on the next screen, do you want to connect to a PC? So meaning we'd use a cable to our USB port and we'd connect it to a computer. Or do you want to connect to an AutoRae 2? So remember earlier how I said when you're first using the AutoRae 2, you'll start with the meter off. You'll put it in the cradle. It'll go through a warm-up sequence and then give you the choice for a bump or a cal. If you already have the meter turned on, you can go to this screen, enter communication mode, select, drop down to AutoRae 2, select again, and then it will be ready to talk to an AutoRae 2 cradle. So then you could literally take the instrument, put it in a cradle, and it will be immediately ready to run a bump check or a calibration. And then if you hit the arrow button one more time, you'll come back to the home screen, which is the main page where you're getting your real-time gas readings.